The other major search method in Java is the binary search. As we described in the previous video, linear search moves across each individual item from left to right. However, binary search allows us to do this in a quicker fashion in less steps. Suppose we wanted to find the number 18 here. In linear search, we would have to go through every single number before 18 to ever find it. With this being a short example, that's not too bad. But let's suppose we wanted to find something in thousands of numbers. The linear search would take way longer than the binary search would. So here's what I have to set up. I have here the code for how a binary search works. I have also here the same array list with the index numbers, which is what we're going to work with. And then we're going to walk through how this code works. And then I'll show it in a coding example. However, it does not show it as clearly as this table will. So here I have an array list of 10, and we're searching for the number 18 in the list. So I'm going to walk you through exactly what the computer is doing in the binary search. I'm also going to go ahead at this time and switch low and high, just because the low number changes a lot in this example. So let's take a look. Our low always starts off at 0. That is our index number. So it's always referring to the first index number in position 0. Our high is going to be the list.length minus 1. So in this case, it's 10 minus 1, which is 9. So our while loop is going to run while high is greater than or equal to low. So in this case, it's going to be yes, high is greater than or equal to low right now. And then it checks what is happening. So let's check it out. What is the list.middle? Right now, our middle is low plus high divided by 2. So 0 plus 9, and this is going to give me the ability to move these over real quick. And let's figure out what our middle is. I'm going to adjust that. Actually, I'm going to move this over and move the middle here. Our middle is 9 divided by 2, which with integer division is equal to 4. So, and our list middle, which would be the 4th position, is the number 10. So we can pull that in there. So now we're checking the 3 steps of the if statement inside. Is the search, which is the number we're looking for, 18, less than the list.middle? Is 18 less than 10? The answer here is no. Is the search equal to the list middle? Is 18 equal to 10? And the answer here again is no. So this means that, take a look, the low is now equal to middle plus 1. So our middle is 4, so our new low number for the next loop round is going to be 5. And our high is going to be 9. So what we have essentially done there is we have eliminated any index prior to 5 from the list. So we have cut the list essentially in half. So we go through this repetition again. Is high still greater than or equal to low? 9 is greater than or equal to 5, so we type yes. The middle is now equal to the low plus high divided by 2, so 14 divided by 2 is 7. And in the 7th position, we have the number 16. So we check, is the search less than list the middle. Is 18 less than 16? The answer is no. And we also know that they are not equal. So we go to the else again. Low is equal to middle plus 1. So middle is 7, so we make this 8. Again, we have eliminated half of the list. So we have 8 and 9. 9 is still greater than or equal to. 17 divided by 2, an integer division, is 8. And at our index 8, we have the number that we're searching for. So is it less than? No. Is it equal to, though? Yes. So in this instance, we took what would take 8 or 9 steps in linear search, and we found it in 3 steps in binary search. This is an example where we found the correct one. I'm going to go back here in a second, redo these exact same steps when we do not find it, and show you how the loop breaks. That'll be in the next video.